Hello guys, today we'll be solving a practical example on regression analysis. The question says, the following data are a result of an experiment on the application of fertilizer on the yield of maize. And these are the data. We have amount of fertilizer applied in kg, which is X. Our X is normally represented as what? The independent variable. And we have what? The yield of what? Yam in kg also, and is represented as what? Y, which is the dependent variable. You know, in regression analysis, we have dependent and independent variable. So, and these are the values obtained. Now the question says, fit in the regression line of y on x. That is to say, to fit in the linear regression model. And B, they say you should predict the yield of maize when x is equals to 20. So let's start. You first of all write down the model that you are trying to fit in. So our regression model, we have y is equals to beta naught plus beta 1 xi plus beta 1 x plus ei. This beta naught is called the intercept, and this beta 1 is the slope. Okay, and this y is the dependent variable and our independent variable x. So this is the equation connecting both the dependent variable and the independent variable. And this epsilon I is the error term, which they call the error term. So what are the parameters needed in this model? We need our what? Beta naught and beta 1. And here are the formulas for calculating the intercept and the slope. Now, our beta naught is equal to y bar minus beta 1 cap x bar. This is the formula for obtaining the intercept of this model. And the beta 1 is given as beta 1 cap is given as n summation xy minus summation x summation y all over n summation x squared minus summation x all squared. There are different formulas for obtaining the beta naught and what? The beta 1. So, but we are using what? The least square estimator, which is given as beta 1 cap is equal to n summation xy minus summation x summation y all over n summation x squared minus summation x all squared. Okay, so this is the data. Let's formulate what do we need from this formula. Our n, we already from the data, we already have our n. The n here is the number of observation. What did I say? The n here is the number of observation. From the data, we have our n to be 7. So the number of observation in the experiment is 7. So let's formulate the table so that we can get the values of our x, y, and its summation. Okay. So this is the data here. We have x, y, this is 3, 5, 8, 10, 16, 16, this is the data, and from the formula we have that our beta 1 beta naught cap is equals to y bar minus beta 1 cap x bar. So for you to obtain the beta naught, we first of all obtain the beta cap, since the beta naught involves what? The beta 1, which is the slope. So and our beta 1 cap is equals to n summation xy minus summation x summation y all over n summation x squared minus summation x all squared. Okay, so for you to get the beta 1 in our table, we need to have what? The product of what? X and what? Y, which is multiplying the values of x and its corresponding dependent variable, which is y. So we have our column here, which is xy. Now 36 multiplied by 3 will give us 18. 5 multiplied by 8 will give us 40. And 8 multiplied by 9 will give us 72. 10 by 13 will give you 130. 130 will give us 384. 16 by 16 times 24 will give us 384. 17 times 22 will give you 374. And 23 times 30 will give us 690. Okay, from the formula also we also need what? The value of x squared, which is each of these independent variables squared. So we generate another column, which is x squared. Now we'll be squaring each of these independent variables, which is 3 squared will give us 9, 5 squared will give us 25, 8 squared will give us 64, 10 squared will give us 100, 16 squared will give us 256, 17 squared will give us 289, and 23 squared will give us 529. Okay, and the formula says for beta 1, which is n summation xy, this n, I have, as I earlier said, this n represents what? The number of observation. So if you count the number of observations that we have 1, 2, 3, 4, 5, 6, 7. Okay, so our summation xy here, it will be summing over the range of 1 to 7 of this xy. So summation xy is equals to, when you sum this column of xy, the product of xy, you will have 1706. Summation x squared will give us summation of x squared, which means you are going to sum this column from 1 to 7. We have 1272. Now we need summation x, which is summing over the range of x from 1 to 7. We have summation x to be 82, and summation y is equals to 112. Okay, what else do we need from this formula? Nothing. So we are going to substitute. We'll be substituting the values of each of these into this formula to obtain our intercept, to obtain our slope, which is the beta 1 cap. Okay, so putting it in the formula, we have our beta 1 cap to be 7, because our n is 7. multiplied by summation xy, which is 1706, minus summation x, which is 82, multiplied by summation y, which is 112, all over our n, which is 7, multiplied by summation x squared, which is 1272, minus summation x, which is 82 squared. Okay, when you multiply this will have when you multiply, you will have 11,942 minus, when you multiply the 82 times 112, you have 9184. Okay, all over what? When you multiply 7 times 1272, you have 8904, minus, when you square 82, you have 6724. Okay, if you do your addition and subtraction, you have 2758 all over, because this minus this will give you 2758, all over 2180, which when we divide we'll have 1.26514. We'll have 1.26515. Okay, so our beta 1 cap, which is the slope, which is the slope, is equals to 1.26514. This is our answer. So now, but in the model, we still need to get what? The intercept, which is the beta naught. And our beta naught cap, this cap represents what? This cap I'm putting here represents the estimate. So we call it beta naught estimate, is given as y bar minus beta 1 cap x bar. And from our arithmetic mean, we know that y bar is equals to summation of y all over what? The number of observation, and our x bar is equal to summation of f all over what? N. This implies that y bar is equals to 112 over 7, which is equals to 16, and x bar is equals to 82 divided by 7, which is equals to 11.7143 approximately. So our x bar is equal to 11.7143 approximately. So having gotten the value of x bar and y bar, we have to what? To fit it in this formula, which says that beta naught cap is equals to y bar minus beta 1 cap x bar. So putting it in that formula, we have our beta naught cap to be our y bar, which is 16, minus our beta 1 cap, which is 1.26514, multiplied by our x bar, which is 11.7143. Okay, so if you multiply this, we have that if you multiply 1.26 multiplied by the x bar, it will give us 14.82023. Okay, this implies that beta naught cap is equals to 1.1798. This is our beta naught cap. So we have gotten the parameters needed in the model. We have our beta naught cap and beta 1 cap. We only have these two models because we have only one dependent and independent variable. So the question A says fit in the linear regression model of y, which is the dependent variable, on x, the independent variable. So for that option, for that question A, they say we should fit in the linear regression line of y on x. So by having gotten our parameter beta naught and beta 1, so we simply put it in the equation. See the equation here. The equation says, this is the regression equation, y is equals to beta naught plus beta 1 x. So we'll have, putting the value of beta naught here, we'll have y is equals to 1.1798 plus our beta 1 is 1.26514 x. This is the linear regression line of y on x. So this is the answer to question A, which says we should fit in the linear regression line of y on x. Now with this equation or this regression line, you can predict the value of y, which represents the yield of maize. You can with this equation you can predict this value of this y when a certain when a certain quantity of fertilizer is being applied. So the question B says we should predict y, that is, we should predict the yield of maize when 20 kg of fertilizer is being applied. So what to do, we just put in, this is the regression line we derive from the data set. Okay, so our y when x is 20, predict y when x is equals to 20. Okay, so when x is equals to 20, we substitute the value of x. This is y is equals to 1.1798 plus 1.26514 multiplied by 20, because our x is 20. So if you do the summation, you have that our y is equals to if you do our summation, you have that our y is equals to 1.1798 plus 25.3028. So adding 25.3028 to 1.1798, you have that our y is equals to 26.48257. So guys, this is the answer, or this is the value of y, the dependent variable, when 20 kg of fertilizer is being applied. Okay, so we have answered the question. Now in our next class, I will explain what the intercept and slope represent the practical interpretation of the intercept and the slope. Thank you, guys.